Howdy folks, Mr. Reed here, and welcome to One More Question. I'm going to be taking a look at a logarithmic equation, or an equation that has a logarithm in it. And this one I'm going to do at what would probably refer to as a medium level. I'm actually going to have to use, I don't have to, but I'm going to choose to use a logarithm law in order to solve this. Depending on how long it takes, I might show you another method to deal with this sort of thing. The nice thing is, once you get to a certain algebraic comfort, you kind of have some options as to how you see the question and how you'd like to pick through it. So if what you're looking for is dealing with an equation with logarithms built into it, solving for a variable, and wanting to do it at kind of like a nice medium level, you're in the right place. So let's get to it. Okay, now this one is log base 5 of 2 minus x is equal to 1 plus log base 5 of x plus 3. Okay, now I'm going to just take a moment to point out to you something that's going on here that's going to make this one a tad bit more involved than one that, even if it was a single logarithm, or even if it was two logarithms that were the same base but there was nothing else there. If there was two logarithms of the same base and one was on one side, one was on the other, we could basically just raise those logarithms into the exponent position on base 5 exponentials in this case, because this is base 5 logarithm. We would be using that inverse function, I guess, magic of being able to say that if you take a function and then have its inverse function stuffed inside of it, they actually cancel and it would leave you with just the inside argument, which is really awesome. But we can't just do that simply here. We still can go through the same method if we're careful, and I might do that, as I said, after the fact. But I'm going to show you the method that I would probably default for this particular one. What I'm going to do is I'm going to take my logarithms and I'm going to put them on the same side of my equation. So visually we can see what sort of logarithm rule I'm going to be using. So there we go. I subtract it from the right hand side to move it over to the left hand side by subtracting it on both sides. And now I have two logarithms of the same base that are being subtracted from each other. Some people will call this the quotient rule or law for logarithms. Basically what it allows me to do is I can write those two logarithms as a single logarithm now, with the part that had a positive, which is my first of these two logarithms, in the numerator, and the part that had the negative associated with it is in a denominator position instead. Now we can do some real fancy stuff to show why that's the same thing as putting the negative up into the top part of, like, up here, and then saying that it's a multiplication, but it's a multiplication by something that's to the power of -1, so it flips back into the denominator. You really have a lot of freedom in terms of how you interpret these, but for the time being, I'm not going to really worry about that. I'm just going to say, hey, this is the way I saw it when I started this question, so I'll continue going along here. Log base 5 of, now, the fraction 2 minus x over x plus 3 is equal to 1. I'm now going to write this in exponential form, which is the base 5 now to the power of 1 on the other side of my equation is equal to 2 minus x over x plus 3. So now I'm going to multiply my x plus 3 up onto the left-hand side of my equation, which will give me 5x plus 15. So 5 times x and 5 times 3, distributive property. And then that's still going to be equal to 2 minus x. So I'll move my negative x, I'll add x to both sides, we'll get 6x, and I'll move my 15 over with the 2, and it's going to become negative 13. And so we get a final result of negative 13 over 6 for the x value. Now, I'm not going to, maybe I'll do a quick, like, hey, did it seem to work out? But if I look back up into my original statements, and I just remember that the domain of these logarithms, the inside of the logarithms, they have to be positives, because, and I guess the way that it works is we can't take the logarithm of a value that is 0 or less. So in the case of the first logarithm is 2 minus a negative value of 13/6. That's fine, so that's going to be 1/6 greater than 4. No problem with that. If we move over to the other side of the equation, we would have 1 plus, and then log base 5 of negative 13/6 plus 3, which is 18/6. So we would have 5/6 there as the value inside. Again, totally fine. If we put those two things kind of to through a calculator or something to see if they're equal. I'm sure that's going to turn out fine. For me, I'm just happy that there's no domain issues here. So as long as the algebra was good, we should be in a good spot. I think I am going to try to do it another way and kind of show you a different view of the exact same question. So let's go ahead and do that, which I am going to just copy that thing down again because I don't have it here. Log base 5 of 2 minus x is equal to 1 plus log base 5 of x plus 3. Okay, so I'm going to, as I said, basically do the same thing again, except for this time I am going to raise both of these into an exponent position on a base 5 exponential. So I'm doing a little cheating sort of way. I'm going to basically make a real big 5, and so it looks like these two things are in an exponent position. My equal sign's in a really awkward place now, but I think you get what I mean. So because this is a base 5 logarithm written inside a base 5 exponential right beside each other, so inverse functions acting right on each other, then that totally cancels out, and I'm left with 2 minus x for my inside piece there. The other side is kind of a trap. Yes, it does have a log base 5 as part of the exponent, but it's not the entire exponent. So I'm going to use a little bit of exponent laws in order to make this look different. I'm going to write it down, and then I'm going to talk about it in reverse, because I find most of my students seem to be really comfortable with this particular exponent law in one direction, and it's a total mess going the way that we have to do it right now. So what I did was I split that single exponent up into two different expressions, both of the same base. Now, if I said, hey, what do? We have a 5 here. Whoops, sorry about that. A 5 here and a 5 here. Oh, that's the same base. And they're being multiplied. What can we do with the exponents? Almost all my students would say, you can add them, which is great. That's how we could come up with the expression that's above it. But if I said I have a single base of 5 with an exponent that's in two pieces, two terms that are being added together, what can I do with that? Crickets. That's what I get. But it can be put back down to that other expression, which is really, especially when dealing with these logarithmic equations, that is a very important thing to start being comfortable with, is working kind of back and forth with the exponential laws. It can help you in a lot of situations, including this one here, if you decide to approach the question this way. All right, so now my second part there, the second part of after my dot multiplication symbol, is going to be 5 to the power of log base 5, and that's all that's there. So it's, again, directly an exponential base 5 applying on a logarithm base 5, cancels completely, and leaves us with x plus 3. So we get an expression that looks like this. This should kind of look familiar if you remember what was going on in the last attempt at this question. So you have the 5x again, the 15, the 2, and the minus x. Move our x over to the right-hand side, get 6. Move the 15 over to the left and get negative 13. Divide both sides by 6, and we get that exact same expression of x being equal to negative 13 over 6. I'm not trying to tell you that one of these ways is better than the other. The second method I find maybe takes a little more care. So don't be tricked into doing things with an exponent that's more complicated than just a logarithm expression, where you think that things cancel out very directly. You have to be a lot more, I guess, be making a very just choice to be doing exactly what you're doing, and you have to realize that it's got to break up into those pieces. It's two separate exponential expressions, both with a base 5, and continue on down from there. So hopefully you liked one of those methods and you feel like you could tackle a problem that looks kind of like this. If you did and you appreciated seeing this, like and subscribe. And as always, take care, folks.